Hi students, let's try to understand the Faraday second law of electrolysis. So the first law we have already done, that is the amount of substance deposited at electrode will be proportional to amount of current pass. But in case of the second law, when it is connected in series, when the more than two cells are there, then it is applied. And what the law say, when same quantity of electricity pass through two or more electrolytes connected in series, then amount of ions deposited liberated at electrodes are directly proportional to their equivalent weight. That is, and what is the equivalent weight, student? Equivalent weight is molecular mass upon n factor. Now, if W1, W2 be the amount of ion deposited or liberated and E1, E2 be the equivalent weight of the ions, then W1 proportional to be E1 and W2 proportional to E2. So, W1 by W2 is equal to E1 by E2, or better you can write W1 by E1 is equal to W2 by E2. So, either you apply this or this, that you need to keep in mind. Now let us try to understand, student, the problem we are going to see. This is the NCERT problem, problem number 16. They are saying, this is exercise, 3 electrolytic cells three electrolytic cells A, B, C containing solution of ZnSO4, AgNO3, CuSO4 respectively are connected in series. So first of all, let us see, this is the 3 electrolytic cell we are making here. So this is the 1, here is going to be 2, and this is going to be 3. Now this all the cells is having the electrodes. So we are mentioning the electrode. And one more things which you have to keep in mind, that these electrodes should be connected in the series. So we are connecting to this to the battery, students. This is the battery here. So, and these electrodes are internally connected like that. They are saying, suppose this is the A, here this is B, this is going to be electrode B, and here is C. They are saying ABC containing solution of ZnSO4. You see, this is ZnSO4. Next one is AgNO3, and last one they are saying, students, CuSO4. A steady current of 1.5 ampere was passed through the DRAM. So how much current is there, student? They are talking 1.5 ampere. Then how much silver is deposited here? You see, on this place silver is deposited. How much? 1.45 gram. This much of silver deposited at the. Now the question, you see, cathode of the cell B, here is they are depositing silver. How long did the current flow? So they are asking, how long did the current flow? Next one, what mass of copper and zinc were deposited? So WZN they are asking, student, and WCU also asking, time also asking, student, right? So see, student, according to which law we have to apply? According to Faraday's second law. Faraday's second law. According to Faraday's second law. So what is this, student? If you talk about Faraday's second law, so W1 upon E1 equal to W2 upon E2 equal to W3 upon E3. Now suppose this is for zinc, this is for silver, and this is for copper. This one, okay. So any two you can compare, student. So case 1, okay, from cell of Zn and what is Ag. We are connecting this one. So what is there? WAG upon EAG equal to what will be there is student WZn upon EZn. This we have to. Up WAG they have given student how much silver is deposited 1.45 gram. This is silver is depositing 1.45 gram. So here we are mentioning 1.45 gram and equivalent weight of silver. So EQ WTAG if you are silver, so that is molecular mass upon N factor. And what electrolyte they have given AgNO3, so N factor is 1, so 108 by what will be there, N factor 1, so it is going to be 108 only. So here we are mentioning 108. This side is WZN, this we have to calculate. EZN equivalent weight of Zn. So what will be their molecular mass upon N factor, and ZnSO4 is there, so valency factor is 2. So if you are checking this one zinc molecular mass, so it is 65.5 upon 2, so it will going to be 32.65. So here we are mentioning 32.65. So WZn if you are calculating student, so 1.45 multiplied by 32.65 divided by it is 108. So it is going to 0.4383 gram. This is now we have to go for the, this is the mass of zinc deposited is 0.4383 gram. Now the next case you see student, case 2. So if you talk about case 2, so from you can consider this one from silver and copper electrode, this one copper cell. So how can you do this one? WAG upon equivalent weight of Ag equal to WCU upon equivalent weight of Cu. So WAG already 1.45 gram. Equivalent weight of Ag we have done already, this is 108. So this is 108. WCU they are asking student, and equivalent weight of Cu. So copper is what is copper, EQWT copper is equal to, that is molecular mass upon N factor, and molecular mass is 63.5. N factor CuSO4 2 positive charge, so valency factor is 2. So so what we can do here, you can divide this one. So 31.75 will come, 31.75. So here 31.75. So WCU if you are calculating, so 1.45 multiplied by 31.75 divided by 108. So how much it is going to come student? This is coming 46.0375 upon 108. So it is depositing 0.4262 gram student. So amount of copper deposited, that is 0.4262 gram student. This is our required answer. Now one more things they are asking student, how long did the current flow? So how long did the current flow? How can you do student? So Q is equal to IT. So T is equal to Q by I. Q is equal to, you can write total charge. This is what? Total charge. Okay. Upon what is there student? Current. Total charge is how much student? This is the NF. Current how much student? That is the I. This is to suppose from the, in each case you will get the same. From Ag electrode, silver electrode you see. So 1 of Faraday, if you talk about the Faraday constant 96,500, and current if you see student 1.5 ampere is there. Okay, see read the question for which portion they are asking. Time for what? Of silver deposited at cathode B, how long did the current flow? For the silver itself they are asking. Now what we need to do student, we need to divide this one, and then we will be able to get the answers. So it is the 96,500 divided by 1.5. It is coming, student, 64,033. This is the second, this one. If you are converting into hours, student, so what will be there? Divided by 60 and again divided by 60. So it is or equal to 17.87 hours. If you talk in the different form, student, if you can take the some other electrodes, so still in that case also you will get the same results. So thank you, students.